All right, guys, so to begin with, we are looking at our lesson for today is average value of a function, which is found in section 6.2. This is also known as the mean value of an integral. Now, that sounds like it would be called a mean value theorem. However, last semester, you learned about the mean value theorem whenever we were doing derivatives. So I want to make sure that you understand mean value theorem is not the same thing as finding mean value of a function. Okay? Now, in looking at this, mean value theorem did work with derivatives. Basically what happened was you would be given a graph. Typically you would have a beginning ordered pair and an ending ordered pair that were different. So let's say this ordered pair was the A f of A ordered pair, and this ordered pair here was a B f of B ordered pair. Now what the mean value theorem told us was that f prime of C, the derivative at some C value, was supposed to equal f of A minus f of B all over A minus B. Now f prime at C, that was the derivative, was supposed to equal this fraction. What does this fraction stand for? That's slope. And it is the slope between the beginning and the ending values that you have right here. All right, so the stipulation, though, was in order to make the conclusion of the mean value theorem, two things had to be true. First thing that had to be true is your function had to be continuous. Now, if the function is continuous, that means that what I draw between these two red dots cannot have any what?
Gaps.
Any gaps. It has to be, I put my pen down, I draw it. I can't have any gaps. However, mean value theorem had one more stipulation. In addition to not having any gaps, any holes, asymptotes, or anything, it also had to be differentiable. Now, it's possible to have a continuous function that's not differentiable. What does that look like? Sharp change in direction. So think absolute value. That would have a derivative that's undefined. What else? Very good. So think of your root graph, so to speak. I call it that swimmer graph, where you will have a vertical tangent at a particular point. So continuous, you can't have any breaks. Differentiable means you can't have any sharp changes in direction. You also can't have any vertical tangents. So pretty much what that means is the curve that I need to draw between here has got to be a nice, smooth curve. So just an example that I'll do here, I could go up, I could go down, I could go up again, but I've got to begin and end at those red points. All right, now as long as you have a nice, smooth curve like that, mean value theorem tells us that the derivative somewhere between A and B is going to have to equal the slope between the first and the last points. So pictorially, guys, the derivative is the slope of a what? Tangent line. Whereas this over here, this slope is the slope of a secant line. So the secant line is going to be like this. Will you agree that secant line has a positive slope? Okay. If that has a positive slope, mean value theorem tells me that somewhere between here, I should be able to get a slope of a tangent line that is equal to the slope of the secant line. So, as a matter of fact, it looks to me like I might have two places. Notice right about here, if I were to do the slope of the secant and tangent line, and right about in here, will you agree those little slopes right there are going to be parallel to the black slope? Okay, so that is pretty much what the mean value theorem says. Mean value theorem, though, is talking about a derivative. This is an average slope, in other words. The derivative is going to have to equal your average slope. That is different from what we're looking at in this section today. Now, the average value of a function sometimes stated as the mean value of an integral, it does have this as its formula. Now on the formula, you'll notice that it does indeed have an integral. It also has a fraction out in front of it. And it says that this is finding the average value of f of x. Well, notice f of x is the function that's sitting over here in the integral. All right, now let's talk about an application of this or a situation of this that might make sense to you. An average value of. Well, I could find an average value of your test scores. Any teacher could. Calculus, chemistry, any class that you happen to be in. If I wanted to find the average value of your test scores, what do I do first? Add them all together, okay? That means that this formula somewhere is adding all of those functions together, all of those function values together. What part of it is adding all the function values together? The integral. This right here is adding all of those function values. Think of it adding all your test scores. Now, after I add all your test scores, if you want the average test score, what do? Divide by some number, and that number is how many you've added. Okay? Well, that means here I'm also somehow got to divide by how many of those things that I added. Where is that? That 1 over b minus a. That right there, that from a to b, that's how many you've added. So 1 over b minus a is the same thing as dividing by how many of them that you've added. Make sense? All right, very good. We're going to move on then and look at some examples. Do you all remember seeing this on a couple of those FRQs before the break? It had a fraction out in front of it on those scoring guidelines. And some of you asked me about it, and you were fine as soon as we talked about it, but this is pretty much what it was doing. All right, now the first example here, this is a much more basic one, but I want you to find the average value of that function over the interval from -3 to +6. All right, guys, now in doing this one, if you are asked to find an average value of this function, first thing you need is a fraction out in front. What is my fraction this time? 1 over 9. Very good. And I need an integral. What is my lower bound? -3 and upper? 6. All right, now the function that I have sitting right here should be
4x
Very good. All right, and then technically there's a dx sitting out there because that was the independent variable that was used. All right, now from here, this happens to be one that you could have done by hand. However, I want you all to practice doing them in the calculator. We practiced a lot doing them by hand, and do not think that your calculator won't give you a correct answer. So I want to review with you what steps to go through so that you can get the calculator to spit this answer out very nicely. All right, so pull my calculator up, clear out whatever I've got in there. All right, it is math 9. Very good. So I'll go math 9. And then I put in the function. So we'll do 4x cubed minus 5x plus 3, comma x, comma -3, and then my upper bound is 6. There's my parentheses, hit enter, and I'm getting 1174.5. Right, is that my answer? All right, got to multiply by the fraction. The fraction was 1/9. That's the same thing as dividing by 9. Very good. I'm very excited back there. All right, so that gives us 130.5. All right, now in looking at that, guys, were there any units with that problem? you don't need units with your answer, but be very careful. If there are units in the problem, be sure to put units with your answer. All right, number 2. This one is more indicative of what you can expect to see. It is more of your word problem scenario. Function that you're given is of an object. It has its velocity, and it does give you units. So down here for part A, when you're asked to find average velocity over the first 10 seconds, it had units, so make sure your answer has units. And then part B, I want to know, is the average speed going to be the same answer as average velocity? Now I'm going to give you a few minutes to try this one, and then we'll come back together and talk about it.
I can't do the math.
All right, in looking at this, average velocity, it means again, I've got to have a fraction out in front. What should that be? Number 10. All right, and then the integral, what should my bounds be? 0 to 10. And the function that's sitting here is? V of t. Very good. So I'm going to write in the 3t squared, but if you put v of t, that's fine. And then the independent variable was t, so make sure you put dt here. All right, now at that point, put that in the calculator, and then it should spit out an answer of 49. All right, and this had units, which means my answer should have what units? Feet per second. All right, any questions? All right, I'm pleased. However, most of my students in the past have questioned those units. They haven't questioned that the units should be feet per second, because they do know average velocity means the units should be the same as velocity, which is feet per second, but they question why the units for this are going to be feet per second, because they remember when you find area underneath a velocity function, what would your units be? Feet. So this integral right here has got the units feet. Why did it suddenly turn to feet per second then? That 10 seconds. When you do 1 over 10, that is the per second situation. So this right here, per second, multiplied by feet is going to give you the units feet per second for your answer. Okie doke? All right, now for the important question. Is average speed going to be the same as average velocity? All right, Brian?
Yes.
Yes. Why?
Because speed and velocity are the same.
Speed and velocity are always the same. All right, I'm seeing some heads shaking. Charlie, what's wrong?
Velocity can be negative, but speed's always going to be positive.
All right, velocity can be negative, but speed is always going to be positive. All right, well, this average velocity I got here is positive. So does that mean that average speed has to be the same positive number? No. Okay, so would this 1/10 change? No, so I'll keep that. Are my bounds 0 to 10 going to change? No. All right. In order for this answer here to be the same as the A answer, that means that this velocity function would have to be what? Absolute value. You want it to always be positive. Is it possible that this could have always been positive? Yeah.
Yes.
It's possible, but to make sure, you want to make sure that you put this in absolute value. So you've got the 3t squared minus 12t plus 9 dt. Be sure you put the absolute value to ensure that you get the correct answer there. Okay? Yes, ma'am. Yes. Yeah, that would be non-differentiable, and that doesn't apply to this. Okay. This is the mean value for integrals. It's not the mean value theorem. Okay? All right, now on this, when you all plug that in, absolute value in Math 9 takes longer to calculate. Did you all see that? All right, what answer did you get? 7999, and it kept going, didn't it? Okay, so let's talk about, if we're answering this, how many of those 9s are we going to need for our answer? You need at least 2 of them, okay? Now, if you choose to, instead of truncate, if you choose to round, then your answer should be 49.800. I do not know what the AP exam reader would do if you put 49.8. I agree, 49.8 is equivalent to 49.800, but I would not chance it. I would put the zeros there just to be sure. Or truncate. Truncating is fine, just cutting off at the 3 places. All right, and on this, what should my units be?
For the 49.799, do we have to put the bar on top of the 9 so that
No, you don't have to. You could. It wouldn't be a problem if you did. Okay? All right, any other questions? All right, now let me mention one other thing that happened on part A. Nice young lady, first period. She asked me, she said, well, for average velocity over the 10 seconds, why can't I just treat it like the mean value theorem and find the velocity at time 0 and velocity at time 10, add those together and divide by 2? Wouldn't that be the average? It's not all of them. Think back to the test scores. What would that be the same thing as doing? Brian?
It'd be like taking your first test score and your last test score and then just cutting out everything in the middle.
Yeah, you could have made hundreds on all those in the middle, but the first one you made a 50, and the last one you made a 60, so I'm going to give you a 55, and y'all are going to be happy, even though all of them in the middle you made 100. Okay, so you got to make sure, that's the reason we need the integral to add up all of the velocities or all of the test scores in between there, not just the first and the last. You see the difference? All right, very good. Now, your assignment for today